everyone. I'm Dr. Owl. I am interested in neurobiology very much. Oh, seeing me speaking seems to make you a little surprised. Actually, what we are going to discuss today is how people can understand others' speech and how people can produce language. Let's uncover the secrets of language function in our brain together. The cognitive processes of language are very sophisticated. We can make a simple analogy here. When we use a computer to process some information, at first we have to input information by hardware equipment like mouse or keyboard. Then the CPU of that computer can make appropriate calculation and output the calculated information through monitors or printers. In the same way, when the brain deals with language information, first it needs to receive that information. It depends on the auditory system to hear the speech or on the visual system to read the words. The auditory and visual cortices then send messages to the language center of the brain, in which the language information is processed. Speech and words can now be analyzed and interpreted. After the brain comprehends the information, it may want to output some messages. That is expression. The language center will connect the motor cortex, which is in charge of hands and mouth, and then output information by speaking or writing. What's worth noticing is that the brain is involved in all these three stages, and the language center of the brain is especially related to processing and expression. After the former introduction, I believe that now you have some basic ideas about how the brain processes language. In this section, I am going to introduce language-related brain regions, focusing on their functions and their location. In the past, early neurologists have tried to find out one-to-one relationships between the brain areas and functions. To do so, they observed patients who suffered from brain injury, matching damaged brain areas and the loss of function in patients. This kind of neurological study method is called localization. In 1861, French neurologist Paul Broca studied the brain of aphasic patients, which were people who were unable to talk. He found that these patients who couldn't speak or say anything meaningful had a lesion in the left side of their brain. The lesion site was later located and named as Broca's area. The major function of Broca's area is speech production. It controls the motor function involved with speech production and is related to the fluency and articulation of speech. In 1876, German neurologist Karl Wernicke indicated that lesions in another area of the brain would also cause language problems. However, patients who had lesions in that area showed different major symptoms. They couldn't understand language well. This area was named as Wernicke's area. It is also located on the left side of the brain. Wernicke's area is considered to be the language comprehension center, enabling people to understand both written and spoken language. Further experiments showed that most people's language cortex, that is, Broca's area and Wernicke's area, are located in the left side of the brain. When processing language, the activity of the left side of the brain is 3 times higher compared with the right side. Different brain regions have to communicate with one another frequently. Therefore, brain regions are connected by nerve fiber tracts. Nerve fiber tracts are just like highways and railways connecting brain areas, shortening the time of sending messages. When we want to send something from Taipei to Kaohsiung, we have many types of transportation to choose from. To achieve the best efficiency, we use different means of transport to send different products. The same thing happens in the brain. There are many nerve fiber tracts connecting brain areas. The brain uses different fiber tracts to send neural messages of different functions to achieve efficiency. As you can predict, there are many nerve fiber tracts connecting Broca's area and Wernicke's area. The most important one is called arcuate fasciculus. If the arcuate fasciculus is damaged, a person's speaking ability will be greatly affected. After watching these brain structures, we will in turn introduce some clinical symptoms as practical examples of what we have just learnt. Aphasia is a kind of language disability caused by impairment, which usually results from stroke or brain injuries of specific brain areas. Any damage to language-related brain regions mentioned before will give rise to aphasia. As a matter of fact, Mr. Broca and Mr. Wernicke found Language Center by means of studying patients suffering from aphasia. Manifestation of aphasia falls into various categories due to harm to different areas. For example, Wernicke's aphasia resulted from damaged Wernicke's area impacts on comprehension of language most. Patients with it can usually speak fluently, but their conversations may be full of nonsense words. Word order of their dialogues may be incomprehensible, and some patients may find it difficult to name things. On the other hand, Broca's aphasia, induced by disability of Broca's area, affects speaking most. Patients often fail to formulate speech and can only convey key words in a sentence or short phrases. In the past, neurologists researched into patients suffering from aphasia and hoped to formulate one-to-one relationships between damaged brain areas and loss of function. Nevertheless, with strides in medical imaging, scientists can now observe the activity of brain areas under different circumstances directly using instruments. Knowledge of language functionality of the brain has been made far broader by scientists since. Opinion of brain functionality nowadays is that the relationships between brain areas and functions are not one-to-one, and cognitive processes are accomplished by cooperation of neurocircuits, composed of areas interconnected by sophisticated neurofiber tracts. Although Broca's and Wernicke's area play different roles, they both participate in comprehension and production of language. The truth is that neuromessages of comprehension and production travel by different pathways, and each of which construct distinct neurocircuits. Scientists are now still researching diligently to categorize brain areas and discover more detailed neurocircuits in order to decipher functions of language. If interests are evoked from you by this movie clip, you are welcome to be a neurologist and uncover mysteries hidden under our skulls. This is the end of our movie script, and thank you for watching.